Hello, in this part of the video, we're going to look at the client class. As a client of this class hierarchy, how do we use them and what's special about them? So let's take a look at the test shape. So in test shape, the first one, we go ahead and create a shape object and go ahead and display it. Display S1. Remember when I do this, S1.toString get invoked. And now we create an object of circle and we go ahead and display it, and we create an object of rectangle. And so pay attention here. S1 type is shape, C1 type is circle, and R1 type is rectangle. And now I'm using the is a relationship. Now you see I have S2 declared as shape. That means at compile time, the type information for S2 is shape, the more general one. And at runtime, when I knew a circle. And this assignment is perfectly legal, and actually this is how we use inheritance. This isn't how we use inheritance. This is how we use inheritance. There is a relationship here. So think about this. The left hand side is a shape, so it's expecting a shape. And new circle create a circle. Remember the is a relationship, a circle is a shape. So that's why you can do the assignment. And similarly, a rectangle is a shape. That's why you can do the assignment. But how about this code? Can I say how about this? Can I go ahead and do that? So if I click on compile, it doesn't like that. It says incompatible types. Found shape but expected circle. You see, the left hand side, I'm expecting a circle here. But you give me a shape. A shape doesn't have to be a circle. That's why it doesn't even compile. So the is a relationship here is you can assign an object of subclasses to an object of superclass, but not vice versa. Sometimes we call it subtyping, like circle is a shape. That's why you can do the assignment. But sometimes my students got puzzled. They're thinking about this. I got this question over and over again. So people got puzzled because of this. Think about this. New circle. Remember when you create a circle object, I told you guys before, like it has whatever it inherits from the superclass, which is a position object. So that means circle is bigger than the shape object because circle has a position object and has a radius part. So yeah, that's true. An object of subclass is bigger than the object of superclass because it has something more. So the children always got more added. Okay, so why can you do this? Assign a bigger object to a smaller shoe. Why a smaller box? How could you assign this? So think about this. New circle give you back the address of the object, not the real object. And remember S2, they're not object either. And in Java, whenever we talk about object, they're really pointers to object. So when you do the assignment, you didn't assign a bigger object to a smaller box. They're all just a reference. This is a reference, this is a reference. So they're all just memory address. So there's no such thing as you cannot assign a bigger object to a smaller box because there's no object got assigned. It's just a memory address. Everything's pointer. Alright, so now let's take a look at this called runtime bounding or polymorphism. We will talk more about this next week. That's the third principle of OO programming. So let's see. When you try to display S2, so it's trying to do S2.toString, right? And S2.toString, which toString get invoked? Think about this. S2's compile time type is shape. Runtime type is circle. So exactly which one got compiled got used is the toString in the parent class or the toString in the subclass. Okay, here's a good deal. So because of polymorphism or runtime binding, it did the binding. So runtime, those two means exactly the same thing. Runtime binding means it will check type information at runtime. So the runtime type information for S2 is circle. So it will bound the toString method in circle to this invocation. And similarly, it will check S3, what's your runtime type? It's a rectangle. So it will bound the toString method, the rectangle toString method to this method invocation. So that's something really cool. It's called, the reason it's called runtime bounding because it checks type information at the runtime to say exactly what are you. I know your compile time type is a shape, but it could be any shape. So it will check it at the runtime. That's why it's called runtime bounding. And this big word called polymorphism. Why it's called polymorphism? So I'll just complete this one, toString. So you see, s2.toString, this same line of code, the toString method invocation could mean totally different things. Like if s2 is a circle, the circle's toString method get invoked. If s2 is a rectangle, then the rectangle's toString method is invoked. So polymorphism means the same lines of code can bound with different method invocation. Totally depends on what kind of object this one is at runtime. So that's why it's called a polymorphism. Like one line of code means different method invocation. Totally depends on the runtime type information. Alright, so that's called runtime binding or polymorphism. And when we come back to this one, the toString, we talk about you have to, this is called overriding the inherited toString method. And when you do the overriding, remember we talk about you have to keep the signature or the method prototype exactly the same as your parent class. Otherwise, it's not called overriding, it's called creating a new method. When you create a new method, you didn't turn on the turn on the polymorphism. So you have to keep them exactly the same to enable the polymorphism. Okay. So let's see. Oh, I have a typo here. That's why it didn't compile. Alright, so that's one show of polymorphism, the toString method. And now let's see. I have a list of shapes here. I don't know why it didn't line up. I don't like that. And you see, I purposely say this is a list of shape. I didn't say this is a list of rectangle or circle. So that means now you can imagine when I add something to this list, I can give it any shape. It could be a rectangle, could be a circle, could be a triangle. Okay, and I create an array list of shape, and I first add S1, which is just a shape. Then I add S2, and S2 is really a circle, and then I add S3, and it's a rectangle, and I add a circle. You see, although it's declared as a circle, and here I want a shape, but because circle is a shape, that's why it didn't complain at all. And I add a rectangle. And now, while I'm looping through all those shapes, I'm testing, hey, are you an instance of circle? If you're an instance of circle, I'm going to print you out. So this testing is at the runtime. So you can imagine as C1 is a circle and S2 is a circle. You should see both of them there. And similarly, I test the equals method. Again, polymorphism is getting used. Like when you say dot equals, it's not using the equals method in the parent class. Instead, it's using the equals method in rectangle class. Alright, so this video pretty much I'm trying to convey one idea, the subclassing idea. The subclassing is to say instance of subclass is an instance of superclass, not the other way around. So whenever they need an instance of superclass, you can always pass an instance of subclass. So for example, if I have a method that requires you to give me a shape, then you can always give me a rectangle or circle. They will all work just like this. So if I want a collection of shape, you can give me a collection of circle or rectangle because they are all shapes. But if one method says you have to give me a circle, then you have to give me a circle. You cannot give me a shape. So that's called subtyping or subclassing. And let's just say an instance of subclass is an instance of superclass, but not the other way around. So now think about if I have a method that takes in an instance of an object that's a superclass for every class. That means it's very general. I can pass you anything because everything in Java except the primitive data type, they're objects. So pretty much it's wide open. You can give me anything. Thank you.